On this page, we're just going to have more practice. I'm going to go through it pretty quickly. So I'm going to read out the division problem here. Much more detail is given on the other pages if you want to go back and watch those and then come back to this one. So 2x goes into 4x cubed, 2x squared times. And then we multiply out. And then subtract. So negative 12 minus 2x squared is negative 14x squared. We bring down the next term, which is the 3x. 2x goes into negative 14x squared, negative 7x times. So we get negative 14x squared minus 7x when we multiply, and then we subtract. So here, change my signs. Cancels, 3x plus 7x is 10x. Bring down the 8. And 2x goes into 10x 5 times. So 2x times 5 is 10x. 5 times 1 is 5. So this one does, and I should follow through my full subtraction, change all my signs. This one does have a remainder of 3. So I don't have a ton of room here, so I'm going to kind of squeeze it in, draw a little line, maybe section it off. So the answer to part B is no, right? It's not a factor. And my answer to part C, I am going to squeeze over here. That seems like the only spot where I have room. So if I write this in quotient remainder form, I have 2x squared minus 7x plus 5 plus 3 over 2x plus 1. Moving on to the next one. Now here's something that hasn't come up yet. If I look at the numerator, there's an x squared term missing. Now for my polynomial long division, for everything to match up, we can't have missing terms. It's kind of like if you write the number, and usually this doesn't matter with polynomials, if you write the number 4092, let's say, you can't just cut out the 0, right? It makes a difference. So when I'm dividing, it makes a difference here. So I have to put in 0x squared minus 13x and then minus 12. X plus 3 goes on the outside. X goes into x cubed, x squared times, and we'll multiply it out. So we have x cubed plus 3x squared. Subtract. Change the signs. So that's negative 3x squared. And then we bring down the 13x. So x goes into negative 3x squared, negative 3x times. Multiply it out. And change the signs. Negative 13x plus 9x is negative 4x. So x goes into negative 4x, negative 4 times. So I get negative 4x minus 12. And we'll change the signs. So for this one, we have no remainder. So answer to B is yes. X plus 3 is a factor of x cubed minus 13x minus 12. And the answer to C, I'm just going to write a C in here and cheat. Right? That is my answer to C. I don't have a quotient remainder form. So moving down to our last two. This one is slightly different because I have 3 terms in what's going into the number. It really doesn't change how things work though. So I am going to write this one out and we'll look and see what happens. So x squared goes into x cubed. We still just take the first term and say how many times it goes into the first term. Under the division sign, x times. So we have x cubed, and we just have 3 distributions. So plus 6x squared plus 8x. And we subtract. And change our sign. So that gives me 5x squared minus 30x. And I bring down the 40. So x squared goes into 5x squared 5 times. So that gives me 5x squared plus 30x, and I realize I had a mistake here, right? 38x minus 8x above should be positive 30x. It didn't necessarily have to match up, but I noticed that as we were going through. So 8 times 5, my last part, is 40. And I subtract and change my signs. And everything cancels, so there is no remainder. So part B would be yes, it is a factor. And then part C would just be what we got, which is x plus 5. Now, maybe you noticed this, maybe you didn't. When we had the trinomial, right, out here, the positive was we actually got done with the problem faster because we got down the line faster, right, with the 3 terms. So it's not really harder, it's just a little different. Here is our last one. So how many times does x minus 3 go into x to the 4th plus x cubed plus 2x squared minus x minus 1. X goes into the x to the 4th, x cubed times, multiply it out. And something you might notice with this, you know, versus some other things we do in this class, it's pretty rote, which means pretty much all the problems act the same. So it is a lot of variables and you have to be careful with your subtracting and stuff like that, but the process itself is pretty straightforward. So how many times does x go into 4x cubed? That's 4x squared times, multiply it out. Once you get it, it's usually one of the things that you'll remember all year, and maybe you'll need a little bit of a refresher, you know, when we review at the end of the year, but it is usually something that sticks pretty well. Bring it down. So x goes into 14x squared, 14x times. And we have 14x squared minus 42x. I am slightly running out of room, so let's see if we can move this over. Okay, that should be good. Okay, so I'm going to subtract and change the signs. So negative 1x plus 42x is 41x, and we're going to bring down the negative 1. So x goes into 41x 41 times. So I get 41x. 3 times 41, and this is negative 3 times 41, so that's negative 123. And then we subtract. Change our signs. Negative 1 plus 123 is 122. So we actually have a pretty large remainder. And when you're doing regular integer long division, your remainder is restricted by how big the number is you're dividing by. So when we were dividing by 7, the biggest remainder we could get before we switched over to the next number would be a 6. With polynomial long division, nothing is really off the table. You could have negatives, you could have really large remainders, it's not a problem. So here, part B, definitely no for the factor question. And part C, I have x cubed plus 4x squared plus 14x plus 41 plus 122 over x minus 3.